Programming paradigm is basically like checking underneath the hood of a car and looking at the engine, the methods that are used inside of a programming language. And it can be several different methods in one programming language. A programming paradigm is the style that you use when you're creating or writing your program. For example, how you store a variable or recover data or make evaluations. Languages like Java, Python, Alice, Snap, ActionScript, COBOL, C++, BASIC, Processing, Ruby, PHP, Scratch, Perl. Most programming languages use a programming paradigm, and that is what this learning module is going to be all about. This module will introduce 4 different paradigms: functional, imperative, which is sequential or procedural, object-oriented, and declarative. Functional programming is something that we all became familiar with way back in elementary school. It's basically taking a value, like a specific parameter, and applying it to a set of instructions, like a mathematical operation, and generating a value at the end of the procedure. X, for example, and X could be any number, and adding it or subtracting it or dividing it, maybe another given number, and the output would be after the function was applied. Functions are not always mathematical. It could be simply looking for an event to happen, and once that event happens, the function is then called, and whatever is the methodology that's used for inside of that function will then be executed, and an expected output would be arrived. Imperative programming or sequential programming is like following a recipe. Say, for example, you're following a recipe for rosemary chicken. You need to follow it step by step. Let's say you want to find f of x that equals x plus 3 times the square root of x. You would go about the answer by breaking it down into a series of steps. For example, answer being your variable would equal x. X equals the square root of x. Now answer is the square root of x, and we're going to say answer now equals x plus 3 times answer. Return answer. Object-oriented programming, otherwise known as OOP. In object-oriented programming, you first need to create the object, and where you would do that is something called a class. So we're going to look at a class like a factory. The factory is making performers, a performer object, and every time a performer is needed, an instance of the performer object is called on. So when an object is being used inside of a program, it's called the instance of an object, like a blueprint of the object. For example, we could make a performer and call it a musician. And the details that come from the performer, the kind of performer, the agent of the performer, what the performer does, all of that detail of the performer is stored inside of the object. The object has methods or actions that can be built into it that only that object can do. Perform well, for example. How does it work? All right, you would build an object. You would have a bunch of objects, and you would have them send messages to one another. For example, let's say that we want to create a bunch of instances of performers, and inside of those instances, we would then specify what they would be doing. A conductor would send a message, and that message would be play music. And the other objects, such as maybe the violinist or the flautist, would then wait on the message from the conductor object. They would then go in and have a method that says play song. Object has attributes and behaviors. The way that they will interact is going to be all done through messages being sent back and forth. The declarative paradigm is basically logic algorithms that are used for artificial intelligence. The program itself is telling the computer what is needed, not how to calculate it. An example of declarative paradigm would be in the use of an expert system. Perhaps want to find out the best route to take economically. Information such as the type of car you're driving, the gasoline that you're using, tires on your car. Then you could ask the question of what route should I take to save the most amount of money on the drive. The algorithm behind the scene figures that out. Other data doesn't have to be calculated because of the knowledge database that is connected to the expert system.